Hello again. So today we're going to kind of go backwards in our book. We're going to talk about some real world problems that use systems of linear equations. And actually, systems of linear equations are used all the time in the real world, particularly with computers. Computers can set up these huge systems of equations, not with just two variables like we're drawn, but thousands of variables, and they have thousands of equations that all work together to get some information out. Okay? So for the warm-up, I just want you to refresh yourself, okay? Hopefully you remember from yesterday's lesson about your substitution elimination. Today we're just going to be setting up some of the equations, okay? So it says, what method would you use to solve the following system of equations? Why? Remember, you have substitution, elimination, and table, okay? There's also graphing. We haven't really talked about that yet, but you could choose graphing, okay? And just explain why. Give me a sentence. Why do you choose to use that one, okay? All right. So question 1. They are word problems. You can do these though, I promise. So it says, at a carnival, 700 tickets were sold for a total amount of $5,500. There should be a dollar symbol there. An adult ticket costs $10 and a child's ticket costs $5. Find the number of adult tickets and the children's tickets sold. Okay? So they want to know how many of each type of ticket I'm selling. So as you see here, I've made this chart. Now I filled some of it in for you. But whenever you can make a chart of all, because there's so many numbers and what makes an equation and what doesn't, okay? So we know we have some number of tickets and the ticket sales, right? How much money we're making. Then we also know there are adult tickets and children's tickets. And then the totals for that, right? Now I could put a total for this column over here, but you only need it for one side, okay? So I happen to choose that side. So I told you for adult tickets, we'll call them A. That's the number of adult tickets I have. We're going to call that A amount of tickets. And then however much I get from that, I get $10 a ticket, right? For the adults, $10 a ticket. So however many tickets I sell times 10 will give me the total amount that I make for adult tickets. Okay. Now the children's tickets, let's call that C. And they told me it cost $5 for a child's ticket. So I take the number of tickets and times that by 5 to get the total amount that I'll make off the children's tickets. Okay, so A is the number of adult tickets, C is the number of children's tickets, 10A is the amount I'm going to make off the adults, 5C is the amount I'm going to make off the children. So now I've left some things blank. So the totals, so the number of tickets, how many number of tickets did I sell? 700. So I'm going to put 700 in this column down here. And then the ticket sales, what did I make totally? And they tell me 5,550. All right. 5,500, not 5,150, sorry. Okay, so now if you look at this column, the total means equals, right? So basically if I do A plus C equals 700 and 10A plus 5C equals 5,500, I have two equations, right? So basically this is my first equation and this one's going to be my second equation. Okay, so I'm going to write them left to right now. So I have A plus C equals 700 and 10A plus 5C equals 5,500. Okay. So now I can do what I've been doing all along. I can use substitution or elimination to solve for A and solve for C, right? So in this one, A and C, I can get rid of either one of them. Because 5 is smaller, I'm going to multiply the top one by -5. Because remember, I need one positive and one negative. So I'm going to distribute this in and write it off to the side. So -5 times A, sorry about that, is -5A, -5 times C is -5C, -5 times 700 is going to give me -3,500. And then I'm going to rewrite my second equation. Okay, I'm going to give you 10 seconds to catch up here because we're doing a lot of writing. Remember, you can pause the video at any time. That's kind of the whole point of this exercise. Okay, so now when I add my equations together, so I'm going to zoom in a little bit over here. It doesn't look very focus there. Okay, negative 5a plus 10a is just 5a. My c's canceled, which is what I chose to happen. Okay, and then negative 3,500 plus 5,500 is going to be 2,000. Okay, and if you need a calculator to add these two together, that's absolutely fine. You can do that. I kind of did it off to the side and checked my work a little bit here. So making sure my brain was working right after break. Okay, and then I'm going to divide both sides by 5 to get a by itself. And 2,000 divided by 5. And again, if you really need a calculator to help you out, it's 400. Okay, so that means there are 400 adult tickets being sold at the carnival. Okay, so how many children tickets? How many kids went to the carnival? So I know that A plus C, or the amount of adults plus the amount of children, equals 700. So if A plus C equals 700, and I know A is 400, now some of you can do this in your head. 400 plus what gives me 700. Or you can subtract 400 from both sides, and I get C equals 300. So there were 300 children, which makes sense because there'd probably be more adults than kids to keep an eye on them and whatnot. So those numbers are relatively understandable. Okay, if you only got one child, I might be a little iffy on what my results were. Okay, and again, these are people, so you're going to get nice whole numbers in questions like this. Okay, whenever you're dealing with people. All right, hopefully that wasn't too difficult. If I were to give you a problem like this on the test, I would probably set up the chart for you, make you maybe fill in the totals, and then just write the equations and solve for them. Okay, I won't make you do all of it quite yet. Okay, we're getting there though. All right, next problem. So, Sasha has a riddle. Okay, so riddles, I'm sure you all love riddles. There are two numbers. It says the sum of the first number and twice the second number is 14. So this whole sentence right here, we're going to break that down, and that's going to be our first equation. Okay, try and find another color pen here. When the second number is subtracted from the first number, the result is 2. Okay, that's going to be my second equation. What are the two numbers? So I have to set up a system of equations to figure out what I'm doing. So the first equation, it says the sum of the first number and twice the second number. So I'm adding my two numbers together, the first number and the second number, and that's going to equal some other number. Okay. So the first number, let's call it x. So we'll call the first number x. And twice the second number. So that's just 2 times y. Okay, because the second number is going to be a different number. Okay, is 14. Is a key word for equals. As soon as you see the word is, that's probably where your equal sign is going to go. Okay. Now the second one says when the second number is subtracted from, so I know I'm taking my two numbers and subtracting it, calling it that. Now it says the second number is subtracted from, and we call the second number y, so that's y is actually going to go on the second spot. Okay, so that's going to be very tricky. You got to remember you're actually subtracting it from the first number. Okay, and the first number we called it x. Okay, and the result is, result just means equals 2. Okay, so now I have a system of equations. Okay, now again, you can decide whichever letter you would prefer to cancel. Okay, I happen to notice that this y is positive and this y is negative, so I'm going to multiply my bottom equation by 2. And I've been multiplying my top equation a lot. Okay, so I'm kind of going to do this a little weird. I'm going to pull these down over this way. Okay, so negative 2 times x gives me negative 2x. Negative 2 times negative y gives me a positive 2y. Equals negative 2 times 2, which is negative 4. And then I'm going to bring down that top equation. Let me write it better off to the side here. Okay. And then I'll zoom in. So all I did was distribute the negative 2 in and pull my first equation down here. Doesn't matter which one goes on top, which one goes on bottom. Oh, I'm sorry. Wow, I just totally screwed that up.